Hi, my name is Leah Buechley, and I'm going to talk to you about Slabforge, design software for slab-based ceramics. This is a collaboration with my wonderful graduate students, Melody Horn and Amy Traylor. So slab-based ceramics is a kind of construction whereby you build three-dimensional ceramic forms by cutting two-dimensional pieces out of flat sheets of clay and then folding them up into three-dimensional forms. Our software is software that supports the design of templates that create a range of three-dimensional clay constructions. This is web-based software. It is fully open source. When you open the software, this is the view that you will see. You see your two-dimensional template on the left and your constructed three-dimensional shape on the right. We support two different classes of forms: prisms, which are selected by clicking on the prism tab, and conical forms, which are selected by clicking on the circle tab. The sliders on the right-hand side of the screen let you adjust different parameters of your shape. So we can change the number of sides in this form. We can change the height of the form. We can change the width of the bottom and also the width of the top. And then finally, we can change the thickness of the clay. So we can make a fat form or a thinner and more delicate form. Once we've designed a shape that we are happy with, we can download a PDF that has a set of instructions that tell you both how to build your template and then how to use the template to construct your form. So here you see in the first page, the set of instructions, and then the last page here is our actual printable template. We have used Slabforge in a variety of contexts. So in particular, we've used it in the context of our own kind of developing ceramics practice. You can see some of the forms that we constructed with the software here. We also deployed the software and tested it in the context of an introductory ceramics class that was taught last year at our university. And the instructor of the class used Slabforge as part of a 2-week slab-based assignment where students built a teapot and a set of 4 mugs. We collected images and other documentation that was generated both by the instructor and by the students. And then at the end of this lesson, students also filled out a survey. This is an example of one of the T-sets that was produced by students. For the remainder of the talk, I want to focus on what we'll call productive frictions, borrowing that term from Ron Wackery and his collaborators. And what we mean by that is tensions that we experienced in moving back and forth between the world of software and the physical world of craft. The first friction that I wanted to talk about is what we call representational dissonance. And what we mean by that is essentially that software can't really fully represent the complexity and richness of an entire craft. There are a range of material possibilities that are not fully represented in software, and those possibilities can be obscured or forgotten. Forms often deviate really significantly from the templates they're based on. So for example, here you see a fairly spherical form being constructed from an initial cylindrical template. Because we didn't even attempt to model this malleability of clay in our software, these kinds of possibilities tended to be obscured or forgotten in use of our software. So software can really, we found, narrow and limit our understanding of the design space and craft process because of this distance between what we can represent and what actually happens in the messy real world. That leads us to a second theme that I want to discuss a bit, which is what we term the computational shadow. Here, we want to emphasize that software, even really lightweight software like Slabforge, we found can fundamentally change, and in fact is really likely to fundamentally change the nature of the design process and also the craft process. So we intended Slabforge to be a design support tool. We imagined that we would come up with designs and then use the software to realize those designs. Instead, what we found is that quite quickly, we started using Slabforge as the medium in which we designed things, which is a big difference. When we use Slabforge in that way to make the most complex and interesting designs that we could make with the software. And those tended to be multifaceted, complex geometric shapes. Because of the way in which we wound up using Slabforge and the way that it changed our design process, we found that that also meant it profoundly impacted our craft process as well. In particular, we found that choices that favored computational complexity in software tended to limit the complexity and richness of the craft processes that we employed. These things all brought us ultimately to this question of kind of what we'll term computational balance. So what is the right or like a good amount of computation to include in software when your goal is really to support a traditional craft process? One thing that we found on the positive side is that a little bit of computation really goes a long way. So just the small amount of computation that's in Slabforge provided significant utility, which you can read more about in our paper. But we also found, as we discussed already, that computational complexity is seductive, is generative and exciting, and we really want to use it when it's there. But it might obscure or displace other valuable modes of working that are rooted in particular in craft. So a couple of conclusions and suggestions. One is that we propose that we consider computational modesty as a really valuable and important approach in design software. And we also suggest that we might consider designing to support existing practice before we try to like expand or change that practice. Doing so can reveal really interesting and important subtleties about a material-based craft. Another big takeaway for us from this whole experience was that the context of use is as important as the software, and particularly support materials that we can also design, things like tutorials and curriculum and craft documentation, that those things are just as important as the software and should receive as much of our like intellectual effort and attention as the actual software does. Thank you very much.